In this video, we are going to learn about multiplication of a vector by a scalar. Then we are going to learn about dot product and cross product. So before we learn multiplication, let us learn division. What is a vector by b vector? A vector by b vector in general is not defined. A vector by b vector is meaningless. So now you have learned division. Now we learn multiplication. Okay, multiplication is of three types. First is multiplication of a vector by a scalar. Suppose we multiply a vector A vector by a scalar S. Then we will get a new vector B vector say. And magnitude of this B vector will be same as S times magnitude of A vector. So we can write like this, or we can write B is equal to SA. We understand that S is a scalar and A and B are vectors. But this is a better way of writing. What is the direction of B vector? Direction of B vector will be same as A vector if S is positive. And if S is negative, the direction will be opposite to A vector. Where do we do this kind of multiplication? One example is force equal to mass into acceleration. A is a vector, A is acceleration vector here, F is a vector, M is a scalar. So here we are multiplying a vector by a scalar. Can you tell me one more equation? Yes, momentum. Momentum is P vector. This is mass into velocity, mv vector. So this is how we multiply a vector by a scalar. Now we will multiply two vectors. For multiplying two vectors, there are two methods. First one is known as dot product or scalar product of two vectors. Now please understand that whenever we are doing dot product, the end result is a scalar. And since it is a scalar, there will be no I cap, no j cap, no k cap in the answer. This is a mistake students make. When they do dot product, they write I cap, j cap, k cap. But dot product gives you a scalar. So there will be no I cap, no j cap, no k cap. Please remember this. To write A vector dot B vector, we must put a dot. This dot must be visible. Without the dot, it is meaningless. So you must put the dot. A vector dot B vector. This is how we are going to read this. And this is equal to AB cos theta, where theta is the angle between A vector and B vector. So A vector dot B vector is AB cos theta. Now, suppose theta is variable. When will dot product be maximum? When is cos theta maximum? When theta is 0 degrees. Cos of 0 is 1. So A vector dot B vector maximum when theta is variable will be equal to AB, and that happens when theta is 0 degrees. Cos of 0 is 1. Right? When will A vector dot B vector be minimum? Not 90 degrees, because 90 degrees will give you 0. But 180 degrees will give you minus 1. Cos 180 is minus 1. So A vector dot B vector minimum is minus AB, and that happens when theta is 180 degrees. by radians. What happens when theta is 90 degrees? A vector dot B vector will be AB cos 90. And what is cos 90? 0. So A vector dot B vector will be equal to 0. This happens when theta is 90 degrees. And this is a very important thing for you to remember. Dot product of two perpendicular vectors is 0. A vector dot B vector will be 0 when theta is 90 degrees. What will be A vector dot A vector? A vector dot A vector will be equal to A, and what is the angle between A vector and A vector? Same vector, so angle is 0. Cos of 0 is 1. So A vector dot A vector is A square. B vector dot B vector will be B square. C vector dot C vector will be C square. Very simple. Now what will be B vector dot A vector? BA cos theta. And BA cos theta is same as AB cos theta. Therefore, B vector dot A vector is same as A vector dot B vector. And this is very important. Dot product is commutative. Later, when we learn cross product, we will see that cross product is not commutative, but dot product is commutative. What will be I cap dot I cap? Not I square. I cap has got a magnitude of 1. And therefore, I cap dot I cap will be 1, 1 cos of 0. How much will you get? 1. Therefore, I cap dot I cap is same as J cap dot J cap is same as K cap dot K cap, and all are equal to 1. What will be I cap dot J cap? 0. Dot product of perpendicular vectors is 0. So I cap dot J cap is same as J cap dot K cap is same as K cap dot I cap, and all are equal to 0 in any order, because order doesn't matter in dot product. Dot product is commutative. Suppose we have to find the dot product of AX I cap plus AY J cap plus AZ K cap dot BX I cap plus BY J cap plus BZ K cap. Now let us try to find out dot product in terms of components. AX I cap plus AY J cap plus AZ K cap dot BX I cap plus BY J cap plus BZ K cap. So how will you do the dot product? We will multiply term by term. First we will multiply this with this, then this with this, then this with this. Then we will multiply this with this, this and this. And finally we will multiply this with this, this and this. So how many terms we will get? 3 into 3, 9. So let us do that. AX I cap dot BX I cap. So we'll write the scalars first. AX BX I cap dot I cap. Now I'll multiply this and this. So to get AX BY I cap dot J cap. And now we'll multiply this with this. So we'll get AX BZ I cap dot K cap. Remember, the dot is very important. Now we'll multiply all the three terms with AY J cap. So AY BX J cap dot I cap. AY PY j cap dot j cap. And lastly, ay bz j cap dot k cap. And finally, we'll multiply this with each of these. So what will we get? Az bx k cap dot I cap. Az by k cap dot j cap. And finally, az bz k cap dot k cap. How many of these terms are 0? 6 terms. Wherever they are different, it is 0. So this is 0, 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 this is 0. We are left with only 3 terms. And I cap dot I cap is 1, j cap dot j cap is 1, k cap dot k cap is 1. So now we get a very simple result. Ax bx plus ay by plus az bz. Right? Very simple. So whenever we are doing dot product, we just multiply the corresponding coefficient ax bx ay by az bz and add them up. That's all. For example, 2i cap plus 3j cap plus 4k cap dot I cap plus 2j cap plus 3k cap will be equal to, multiply 2 with 1, so 2 into 1 plus 3 into 2 plus 4 into 3. So what do you get? 2 plus 6, 8 plus 12, 20. Right? No I cap is there, no j cap is there, no k cap is there in the answer. Whenever we are doing dot product, in the end we get a scalar result. What is this dot product giving us? What is actually a vector dot b vector? Suppose this is a vector. This is b vector. Angle between them is theta. What is the component of A in the direction of B? We have learned that component of vector in any direction is magnitude of vector multiplied by cos of the angle between the vector and the direction. So therefore component of A along B will be A cos theta. And A cos theta, if you multiply with B, we get AB cos theta, which is A vector dot B vector. Therefore, dot product is equal to magnitude of one vector multiplied by scalar component of the other vector in the direction of the first vector. This is how we find work. What is work? Work is dot product of force and displacement. So basically this is the product of component of force in the direction of displacement multiplied by displacement. This is what is dot product. Now we have learned dot product. Dot product is also known as scalar product because the end result is a scalar. Now let us learn cross product. Cross product is also known as vector product because the end result is a vector. Remember that. So the final result will have I cap, j cap and k cap. Vectors have I cap, j cap, k cap. So what is A vector cross B vector? Again remember, we must put this cross. Without the cross it is meaningless. A vector cross B vector is defined as AB sin theta. There it was cos, now sin. And because it is a vector, it must have a direction that we call n cap. Now what is the direction of this n cap? N cap is a unit vector perpendicular to both A vector and B vector. This is that smaller angle theta. To find n cap, take your right hand. If your fingers can move easily from A vector to B vector through the smaller angle, then the outstretched thumb will give the direction of cross product. So A vector cross B vector in this diagram is out of the board towards you. What is B vector cross A vector? Now I have to keep my hand like this so that my fingers can easily move from B vector to A vector. Now the thumb is towards me, away from you. Therefore, B vector cross A vector is exactly opposite in direction to A vector cross B vector. B vector cross A vector is not equal to A vector cross B vector. Cross product is not commutative. It cannot change the order. And this is very important. If you change the order, you will get an extra minus sign. B vector cross A vector will be equal to minus of A vector cross B vector. When will the cross product be equal to null vector? We know sine of 0 is 0. Sine of 0 degrees is 0. Therefore, if vectors are parallel or anti-parallel, because sine 180 is also 0, then cross product is null vector. A vector cross A vector is null vector. Right? If you remember, dot product of perpendicular vectors was 0, cross product of parallel or anti-parallel vectors is null vector. So therefore, I cap cross I cap will be null vector. Angle between I cap and I cap is 0 degrees. And that is true for J cap cross J cap and K cap cross K cap. All these are equal to null vectors. What will be I cap cross J cap? Not 1, because you have to get a vector. Cross product gives us a vector. So it will be perpendicular to both of this and obeying that right hand rule which we discussed earlier. So therefore, I cap cross J cap is K cap. What is J cap cross K cap? That is I cap. K cap cross I cap is J cap. Right? What will be J cap cross I cap? No, it will not be K cap. It will be minus K cap because now you have changed the order. So you'll get minus K cap. What will be K cap cross J cap? Minus I cap. And what will be I cap cross K cap? Minus J cap. Right? How to remember all these things? Whenever you start from I and you follow this cyclic order and it is I, J, K, then it is positive. Start from here I, J, K, I, J, K, I, J, K. So that is positive. If the order is I, K, J, then it is negative. Look here, I, K, J, I, K, J, I, K, J. So I, K, J is minus, I, J, K is plus. If you remember this, it will be very easy to find the sign. How to do cross product using components? Again, we can multiply term by term. Let us do that. Suppose you have to find out AX I cap plus AY J cap plus AZ K cap. Now we'll learn how to do cross product using components. Suppose we have to find the cross product of AX I cap plus AY J cap plus AZ K cap. cross bx I cap plus by j cap plus bz k cap. So like we have done for dot product, now we will multiply term by term. So what is the first term we get? Ax bx I cap cross I cap. Write this into this. Plus ax by I cap cross j cap. Ax bz I cap cross k cap. Right? Now we'll multiply this with each of this. So what will we get? Ay bx j cap cross I cap. Ay by j cap cross j cap. Then finally ay bz k cap j cap cross k cap. Right? Now we'll multiply az k cap with each of the terms. So az bx k cap cross I cap plus az by k cap cross j cap and az bz k cap cross k cap. So how many terms you got? 9 terms again. But now how many terms are 0? Only 3. I cap cross I cap is 0. J cap cross j cap is 0. K cap cross k cap is 0. We are left with 6 terms. So let us simplify. Here you got ax by. What is I cap cross j cap? K cap. So k cap comes here. Next term. Ax bz I cap cross k cap. So we'll get minus, because it is order ikj, ax bz j cap. What will come here? Again ikj. So we'll get ay bx minus k cap. Right? Here what will we get? jk I. So plus I. Ay bz I cap. Here ki. So j. So j will be positive. Az bx j cap. Here kj I. So again minus sign will come. Plus az by minus I cap. So these are 6 terms we are left with. Let us take I cap common. What do we get? I cap, there are 2 terms, here and here. Ay bz minus az by. Right? Now let's take minus j cap common. There's a reason for that. Okay, let's take minus j cap common. What is minus j cap? Here. Ax bz minus az bx. Now let's take k cap common plus k cap. So we get ax by minus ay bx. So this is what we have got from the cross product. This we have learnt, but we'll never do it like this again. We'll use determinant to find the cross product. Let us see how to do that. That is very easy. Now we'll learn how to find cross product using determinant. Determinant is a chapter you'll be learning in maths. So this cross product is equal to this determinant. Our determinant will have 2 parallel lines. I cap, j cap, k cap. The 3 unit vectors will be in the top row. The components of first vector will be in the second row. Ax, ay, az. The component of second vector will be in the third row. bx, by, bz. Now how to evaluate this determinant? First write the first element. So I cap is the first element. We write I cap. Then put a bracket. Forget everything in the row of I and the column of I. Don't look at these things, don't look at these things. Multiply this and this. Always first like this. So what do we get? Ay, bz. Then multiply like this. In between put a minus sign. So we get az, by. Right? This is how we get the first term. For j cap, put a minus sign. In determinant, signs will alternate, plus, minus, plus. So now I'll forget everything below j. And we forget the row of j. So that is the unit vector anyway. So we multiply this and this. Ax, bz. Minus az, bx. So j cap, ax, bz. Minus az, bx. Now write the third unit vector, k cap. Forget everything below k. Multiply again this way first, ax, by, minus sign, ay, bx. So we get ax, by, minus ay, bx. Now see the magic. Whatever we have got here is exactly same what we got here. And this is much easier. Right? So doing cross product using determinants is very, very easy. We can practice that and we can become an expert in that. Why do you use cross product? Whenever the final result is a vector, then we have to use cross product. You multiply two vectors and you get a vector. Then you have to use cross product. Multiply two vectors, you get a scalar. Then use dot product. Torque. Torque is the turning effect of a force. Torque is given by the cross product of r vector and f vector. So remember, torque is r cross f. So now we have learned cross product. Now what is the use of all these cross product, dot product? With this cross product and dot product, we can find the angle between two vectors. A vector dot b vector is ab cos theta. So we can get cos theta by dot product. Cos theta will become a vector dot b vector by magnitude of a, magnitude of b, because a vector dot b vector is ab cos theta. How can we get sin theta? Sin theta we get in cross product. So sin theta will be equal to magnitude of a vector cross b vector, because here we get a vector, so look at the magnitude, and divided by magnitude of a vector multiplied by magnitude of b vector. This will give us sin theta. Now using cross product, we can also get a unit vector perpendicular to two vectors. This n cap is perpendicular to two vectors. N cap will be given by a vector cross b vector divided by magnitude of a vector cross b vector. This is how we get a unit vector perpendicular to two vectors, n cap equal to a vector cross b vector divided by magnitude of a vector cross b vector. As we know, cross product is perpendicular to both the vectors. A vector cross b vector, magnitude of this gives us the area of a parallelogram whose adjacent sides are a vector and b vector. So area of a parallelogram will be equal to magnitude of a vector cross b vector. How to find area of a triangle? Triangle is just half of the parallelogram. So area of a triangle is half magnitude of a vector cross b vector. Right? Remember, null vector has got a magnitude of 0. So all the components of a null vector are 0. 0 vector or phi is equal to 0 I cap plus 0 j cap plus 0 k cap. When anything is in equilibrium, the sum of the forces acting on it will be equal to null vector. Okay, the sum of the torque also will be equal to null vector, that will be learning later. But remember this, equilibrium means net force equal to null vector. So now you know about vectors, you know dot product, you know cross product, you know how to find area of a parallelogram, area of a triangle using cross product, how to find angle between two vectors. When two vectors are perpendicular, their dot product is 0. When vectors are parallel, their cross product is equal to null vector. Now, let us learn one more thing. Projection of A vector on B vector is defined as A vector dot B cap. This is the scalar projection. And somebody asked the vector projection, it will be A vector dot B cap multiplied by B cap. This is projection of A vector on B vector. If somebody asks us projection of B vector on A vector, that will be B vector dot A cap. That is a scalar projection. If you want the vector projection, again you multiply by A cap. Okay, A cap you know is A vector by mod of A vector. So if you want, we can write this as B vector dot A vector by magnitude of A vector. And this is also A vector by mod of A vector. So this is projection of one vector on another vector. When will two vectors be parallel? A vector and B vector. How to check whether these are parallel vectors? There are many ways of doing that. The first method is, if B vector is a scalar multiple of A vector, then the vectors will be parallel. Find that B vector is 2 times, 3 times, 5 times. This is the easiest way to check whether the vectors are parallel or not. The second way you can check is if Ax by Bx is same as Ay by By is same as Az by Bz, then vectors will be parallel. The same as that. But this is one way of checking again. You can also check A vector dot B vector. If vectors are parallel, angle between them is 0 degrees. So if A vector dot B vector is same as magnitude of A multiplied by magnitude of B, then the vectors will be parallel. And the last method, we discussed that earlier. Vectors are parallel if their cross product is equal to null vector. So we can check whether vectors are parallel by using any of these 4 methods. Now one interesting question. Pressure is force upon area. Then how is pressure a scalar? Force is a vector. Area can be both a scalar as well as a vector. Volume is always a scalar, remember that. So how is pressure a scalar? How is surface tension a scalar? Pressure and surface tension are scalars because they have a direction that is unique. Direction is there, but that is unique. And that's why it need not be specified. Pressure is always perpendicular to the surface. Surface tension is always along the surface.